Hello, and welcome to the VDM Project update for 2025. I'm Dr. Sabag, and I'm here with Fabio Gallerani, the founder of the VDM Project. I welcome all of you and wish you a happy new year. And our purpose today will be to summarize the work that's been done by the VMR Research Foundation in 2024 and give you some insight into the things that we're working on for 2025. With your support, 2024 was a very successful year. We had 5 peer-reviewed publications, 2 chapters, multiple lectures, and I won't go through all of them, but I will point out some important things. Some of you may recall that we employ ultrasonography to image the vitreous. Vitreous is the gel that fills the center of the eye, and it's there that opacities form, which create shadows that people see as floaters. It's a visual phenomenon, not a structure. These opacities are difficult to visualize just during a routine clinical examination, but we have found that using ultrasound can show a lot of the structure of the vitreous body and can be quantified to give us a sense of whether the case is mild, moderate, or severe. What we never knew was what was the relationship between the ultrasound findings and light scattering. Light scattering means when light enters the eye, it bounces off of any objects in its path, and that disrupts vision, creates shadows that you see as floaters, but also degrades contrast sensitivity, which is the ability to discern between different shades of gray. We never knew whether doing ultrasound was an accurate reflection of the light scattering that was occurring during the phenomenon of floaters. So we were successful in obtaining samples from patients who had severe floaters that underwent surgery. And those samples needed to be maintained fresh. So I organized things in such a way that surgery was done on a group of patients in the morning. I drove to LAX International Airport, and there I met a scientist from Spain who was lecturing in Northern California. And I transferred the specimens, and she was able to go straight to Spain, to her laboratory, and begin the analysis. And it was really a very gratifying experience. We did that on 2 separate occasions and assembled a group of samples that she was able to correlate light scattering in the laboratory with what we measured by ultrasound and by contrast sensitivity before surgery. And there was a very high correlation, meaning the more dense the vitreous and the worse the contrast sensitivity, the more light scattering she was able to measure in the laboratory. So what that did was create a link between our ultrasound measurements and the light scattering measurements done in the laboratory, meaning that ultrasound is a good proxy, it's a good representative of the light scattering phenomenon that's occurring when people experience floaters. And we published that in the top eye research journal in the world. And I'm quite proud about that collaboration. It's giving us very useful information. We also had a publication, a preliminary publication on using artificial intelligence in the interpretation of ultrasound findings in patients who have various conditions inside their vitreous. There were several lectures that were done all over the world to raise awareness for vitreous, but also to educate surgeons about the role of vitrectomy. Now, you do understand that there are alternatives to surgery, but we have a vast experience in performing limited vitrectomy for clinically significant cases of what we call vision-degrading myodysopsia from vitreous floaters. That's what the VDM stands for in VDM Project. It's vision-degrading myodysopsia. So we have done now 289 vitrectomies, limited vitrectomies, for patients with VDM. We also have a comparison group of 362 patients who have floaters, but who chose observation, and we were able to compare the two. The lectures that I was able to deliver to a group of surgeons from Europe in Mallorca, and also to the American Ophthalmological Society, and also to the American College of Surgeons, was focused mostly on the experience with vitrectomy. And the objective was to share with them the high degree of safety and the high degree of efficacy of performing a limited vitrectomy for clinically significant cases. And the more that message is delivered, the easier it will be for patients to at least get consideration from their doctors, but at the most get treatment from their doctors by performing a vitrectomy and curing their floaters. Now, that's not the only approach, and we'll touch on other approaches in a few minutes, but the purpose of going to Mallorca, to San Diego, to San Francisco, and elsewhere in the world is to share our experience with doctors all over the world, lowering the threshold for patients to get consideration and possibly to get cured. We also delivered lectures concerning the diagnostic aspect. The world's largest eye research meeting is called ARVO, and at this past May of 2024, we lectured at ARVO on ultrasonography of vitreous in patients with floaters, but also on the use of MRI to image the movement of the vitreous, because you all are probably aware that things change when you're reading because your eye moves, when you're driving because you're looking to the side view mirror, and the movement of the vitreous can be a very disturbing aspect of living with floaters. So the diagnostics are very important, and we presented those to the International Retinal Imaging Society at UCLA in the spring. But recently I traveled to Singapore and I lectured to the Asia Pacific Vitreoretinal Society, talking about how myopia changes the vitreous and how that causes floaters and degrades contrast sensitivity. So there was a lot of interest, and I think we succeeded in raising awareness within the medical profession of both how to diagnose vision degrading myodysopsia, but also how to treat it at this point with vitrectomy. We are working on a project using an alternative to vitrectomy, that being YAG laser vitreolysis. And in collaboration with colleagues in London, we are conducting a project where we're performing all of our diagnostic tests before, during, and after YAG laser vitreolysis. And we will be sharing the results of that study with the world. I know that YAG laser is done, quote unquote, routinely all over the world, but we've questioned whether it's being done scientifically. And we've also noted the absence of a good scientific study showing does it work or not, and if it does work, in whom is it best used. And I already have some insights into who are the patients that most benefit from YAG laser vitreolysis. Some of you may recall that in the past I was quite skeptical about the use of YAG laser vitreolysis, but having done it myself in a large number of patients, I have come to understand that there's a subgroup of patients who can become very, very happy after a YAG, excuse me, after a YAG laser treatment. So it's not for everyone, and we are defining for whom it is most effective, and we'll be sharing those results with people throughout the world. In a few weeks, I'll be traveling to San Francisco to a meeting of optical engineers. And at that meeting, the new technologies for imaging the eye are presented. And I'm very proud to share with you that in collaboration with optical engineers at the Nicholas Copernicus University in Torun, Poland, we've developed advanced OCT imaging, that's optical coherence tomography imaging of the vitreous body, that we are going to present at the SPI meeting. There will be 73 presentations, and of those 73, 5 were selected as being the top presentations, and our presentation is one of those 5. So there too, we're going to be sharing with people from all over the world the advances that have been made. There will also be a meeting in February where I'll be lecturing to eye surgeons once again to make them increasingly comfortable with the notion that floaters are not a nuisance, they're a disease in some cases, and how to identify those cases, and then how to perform safe surgery to cure those cases. In March, I'll be traveling to Japan because I've been invited to lecture at the Japanese Vitreoretinal Society meeting, once again on vitreous in myopia. We're currently experiencing an epidemic of myopia. It's been estimated that by the year 2050, there'll be 5 billion people in the world with myopia. And one of the parts of the eye that's afflicted by myopia is the vitreous. And a large number of our patients complaining of floaters are myopic individuals. And there is an unmet medical need. So our information, sharing that with people all over the world, is a very useful way to raise awareness and focus on the problem. I should point out that funds that have been donated via the VDM Project to the VMR Research Foundation are used for all of these research projects as well as these presentations at meetings, because I think it's important that the world know there are a lot of people out there with floaters, and they should be treated just like anyone else who has any other disease of the eye. And floater patients deserve our concern and consideration. We have developed diagnostic methodologies, and we have shown the safety and efficacy of vitrectomy. We're now working with laser vitreolysis with great success in a subgroup of individuals, and there are other treatments to come. In terms of research, I have sent 4 dozen specimens of vitreous that I've removed at surgery from patients with vision-degrading myodysopsia for analysis at laboratories at the University of Freiburg in Germany. These are going to be advanced molecular diagnostics that will give us more insight into what causes floaters, and that should lead to new ideas about how to treat those floaters. Specifically, I'm intrigued by the potential of developing drugs that could be injected into the eye that would dissolve the floaters, dissolve the opacities, and alleviate the symptoms of floaters. So that's another one of our objectives in 2025, again, with the support of funding to the VMR Research Foundation. So I think I'll stop here. And once again, thank you for your interest and your support of the VDM Project and the VMR Research Foundation. Have a good year, everyone. Happy 2025.